Welcome back to another video of the channel. My name is Julio. Thanks for tuning in. Before we get started, like, subscribe, hit the notification button, and let's get down to business. So today we're going to be talking about eBGP, but we're going to be running it on Cisco IOS XR. Before we get into the lab, let's get inside the details. All right, so Cisco IOS XR is a modern modular network operating system designed for carrier-grade routing, offering high availability, scalability, and programmability for service provider networks. Unlike the monolithic Cisco IOS, it uses a microkernel architecture for increased stability, runs on high-end Cisco ASR and CRS routers, and features a two-stage commit process for configuration changes to ensure stability. Key features include in-service software upgrades, extensive APIs for automation using Yang models, and a secure self-healing design. And some of these key features are better explained as follows. High availability. In-server software upgrades. Allow software upgrades without interrupting the network. Process restart. Individual software processes can be restarted without affecting overall network operation. Programmability and automation, APIs and Yang models, offers extensive application programming interface and support for modern data modeling standards like Yang for network automation. Streaming telemetry provides integrated data to give network visibility. All right, so let's talk about route policy running on Cisco IOS XR and the similarities and differences it has with route maps running on Cisco IOS and Cisco IOS XE. All right, so Cisco route policies are configuration that dictate how the router handles network traffic or routes, moving beyond standard destination-based routing to control paths based on factors like source, application, or specific features. These policies, often implemented using route maps and the routing policy language, RPL, allow administrators to apply specific actions such as filtering, modifying attributes, or forwarding traffic to different next hubs, enabling more flexible and intelligent network control. The key difference is that iOS XE uses sequential route maps with basic matching and actions for route filtering and policy-based routing, while iOS XR uses a more programmatic routing policy language, RPL, which allows for modular, hierarchical, reusable, and more powerful policy creation throughout a compiled if-then-else structure for complex networks. RPL provides greater control and reusability than the traditional route map syntax found in iOS XE. All right, so the first thing we're going to do is we're going to configure router A. At your left, you're going to see the CLI syntax that we're going to be injecting on that router. We're going to configure two loopbacks and gigabit 0/0/0/0/0 with the corresponding IP addresses, the route policies, and also BGP instance as well. And at your right, we're going to configure router B. At your right, you're going to see the CLI syntax we're going to be injecting on this router. We're going to configure the two loopbacks, gigabit 0/0/0/0 with the corresponding IP addresses, the route policies, and also BGP instance as well. So now that we have explained a little bit about Cisco IOS XR and route policies, let's get straight into CML and let's get started with the lab. Let's get it, guys. All right, so we inside CML now. We're gonna start configuring router A with the loopbacks, gigabit Ethernet 0/0/0/0 with the route policies and also the BGP instance. Always remember before you leave the configuration terminal on Cisco IOS XR to commit so you can save your changes. The commit is the equivalent of doing a copy running config to starter config or write memory on Cisco iOS and Cisco iOS XE. All right, so the reason I'm doing route policies is that by default, Cisco iOS XR has a default command called save BGP policy. If you don't create route policies, you will not be able to advertise any networks to your peer, and also you will not receive any networks from your peer. This command disables this behavior that is being highlighted right now. Always remember to follow everything that I'm doing in the same order in order for you to get the BGP remote AS and your neighbor configured correctly with the route policies, and also then configure the networks they're going to be advertising to your peer. All right, so let's jump into router B. We're gonna start configuring the loopbacks. We're gonna start configuring also the gigabit Ethernet 0/0/0/0/0. We're also gonna configure the route policies and the BGP instance. And remember, in Cisco iOS XR, when you want to apply a prefix list to the route policy that you're creating, the command set is prefix set with the name, and you're going to configure inside the networks that you're going to be receiving or maybe advertising to your peer. All right, so the BGP peering is up. Let's wait a couple of seconds here. And now I'm receiving one route. And if I do a show IP BGP, you will see that since I configure only the 10.0.0.0/24 network on the perfect set, I will learn this route, but not the 10.0.1.0/24, which it was the intention. Now let's go to router A and let's do a show IP BGP. I'm learning the 10.1.0.0/24 and the 10.1.1.0/24, and it's because of the route policy I created outbound on router B, which I specify both networks running on the loopbacks, and it's allowing the advertisement via BGP to my peer, which is router A. All right, so let's say you wanna verify a specific route policy you created. You can do a show RPL route-policy, the name of the route policy, detail, and it's gonna show you whatever you have configured inside. You can also use the show RPL route-policy states, and it's gonna show you all the route policies and their state, if they're active, inactive, or unused. Let's do the same command on router B, show RPL route-policy states. And as you can see, we got two route policies, BGP filter in and BGP filter out. And as you can see, they're both in active state. And to finish up, let's do a ping to the 10.0.0.1, which is running on router A. And as you can see, the ping is successful. All right, so this is gonna be the end of the lab today. I hope you're enjoying the content. If you did, please give it a like. And as always, this is Julio. I'll see you in the next one. Peace out.